All right, now we're on number 5. They give us this function for f of x. Part A says the Maclaurin series for ln of 1 plus x, so instead of 1 plus x cubed, 1 plus x, is this. And here's a general term. Use the series to write the first 4 non-zero terms and the general terms for the Maclaurin series for f. So this is one that we can build just like we did with our 4 memorized series for sine x, cosine x, whatever. The only difference between this expression and f of x is we're basically plugging in an x cubed in for x. So we can say that ln of 1 plus x cubed is equal to, instead of x, x cubed. Instead of x squared over 2, x cubed squared over 2. Now, that kind of drives me crazy, so I would also simplify that. Power to a power, x cubed squared is x to the 6th. Plus x cubed cubed is x to the 9th over 3, minus x to the 12th over 4. Plus dot 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 plus what's happening to the general term? So there's still this negative 1 to the n plus 1. X cubed to the n is x to the 3n, and it's getting divided by n, plus dot dot dot. So that's it for part A. The radius of convergence of the Maclaurin series for f is 1. So they give us r equals 1. Determine the interval of convergence. Show the work that leads to your answer. Now, remember, this series is centered at 0. So the interval of convergence should be 0 plus or minus 1, or basically x needs to stay, our center expression would be x, right? So x needs to stay between 1 and negative 1. Do we include the endpoints or not? So that's what we have to check in this problem. That's really where the work is. So, all right, we have, if we check when x equals negative 1, we have this series that, let's see, where does it start? We have to check this. Here's the general term. I'm going to write this out. It's negative 1 to the n plus 1 times x to the n over n. So does n start at 0? No, because then we'd be dividing by 0. N starts at 1 because you get positive x to the first over 1, and our first term is x. Okay, small detail, but still important. All right, so what do we do when x equals negative 1? So we're putting in negative 1 in for that x. And let's simplify that, because the whole point is this alternating or not? So because these are both base negative 1, you can add the exponents to be 2n plus 1 over n. Now 2n plus 1, if you multiply a number by 2, you're forcing it to be even, and then you're adding 1, which will always be odd. So really this series is no different than the series from 1 to infinity of just negative 1. This will always be negative 1 over n. And that is a divergent harmonic series. It's the harmonic series multiplied by negative 1. So we do not include negative 1. Let's check when x equals 1. Even if you know in your head how this is going to be, you need to write it down for the free response. So when you plug in 1, you're going to get the original negative 1 to the n plus 1. We don't need to say 1 to the n. So that's just there. It's still over n. Now this converges because it's an alternating series, convergent alternating series. So the interval of convergence is not including negative 1, including 1. You can also use inequality notation on that. That's fine. All right, part C. Write the first 4 non-zero terms of the Maclaurin series for f prime of t squared. And then there's a follow-up part, but let's just do that first part first. So, all right, we have a series for f, right? What we wrote for part A, that was equal to f of x, right? So let's come up with a series for f prime to begin with, and we need 4 non-zero terms. So let's make sure that we write f prime out. So here's f of x, f prime of x, and you could write f of x again if you want to. I'm just trying to save some time. So f prime of x is take the derivatives of the first 4 terms. So you're going to get 3x squared minus 6x to the fifth over 2, so 3x to the fifth, plus 9x to the eighth over 3, so plus 3x to the eighth. Again, I don't have to simplify, but it's a nice pattern to see. Minus 12x to the 11th over 4, so minus 3x to the 11th, plus dot, 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 plus negative 1 to the n plus 1. We're pulling down 3n, so 3n over n is going to be 3, and then we get x to the 3n minus 1, plus dot, dot, dot. So write the first four non-zero terms for f prime. Now, we're supposed to do f prime of t squared. This is f prime of x. So what's f prime of t squared? Well, build that, plug t squared into this. This becomes t squared squared becomes 3t to the fourth minus 3t to the 10th plus 3t to the 16th minus 3, excuse me, t to the 22nd plus dot, 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 plus negative 1 to the n plus 1 times 3. Instead of x to the 3n plus 1, it's t to the 6n minus 2, because you're saying t squared to the 3n minus 1. So power to a power, you multiply. Plus dot, dot, dot. So that part's done. If g of x equals the integral from 0 to x of f prime of t squared dt, write the first two non-zero terms of the Maclaurin series for g to approximate g of 1. So there's a lot to do in this one. Okay, let's take a look here. So g of x is equal to the integral from 0 to x of f prime of t squared dt. The only reason the t's are in here is because we're going to integrate and put an x in here. Okay, so we're supposed to integrate these terms, and we put x's back in, right? So if I integrate these terms, then I would get, let's see, 3t to the, oh, sorry, not t, 3x to the fifth over 5, because again, we're going from 0 to x, and the expression g of x, the equation g of x is in terms of x, not in terms of t anymore. Okay, so we're just integrating this, right? Don't overthink it. Integrate these terms. Okay, so minus 3x to the 11th over 11 plus 3x to the 17th over 17 minus 3x to the 23rd, excuse me, over 23, first four non-zero terms, plus general term, negative 1 to the n plus 1 times 3t to the 6n minus 2. You've added 1 to that. Not t. Gosh, x to the 6n minus 1, minus 2 plus 1 is minus 1 over that new expression. Now, did I get that right, or did I screw it up? Double check here. So if we plug in 1, we get positive 3. 6 minus 1 is 5. Yes. Okay, so that does work out. Plus dot, dot, dot. So you can double check your general term, make sure that it starts correctly. All right. And what else are we supposed to do with this? So let's see. So here's the series. Use the first two non-zero terms. I went farther than I needed to. Use the first two non-zero terms to approximate g of 1. So if this is g of x, g of 1 is approximately equal to 3 times 1 to the 5th over 5 minus 3 times 1 to the 11th over 11. We should do the math here. 33 minus 15, what is that? 18 over 55, which reduces to, oh, no, it doesn't reduce. What am I saying? So I would just keep it as 18 over 55. So that's our approximation. G of 1 is about equal to 18 over 55. Do you have to simplify that? I've always been told no. So could you leave it as 3/5 minus 3/11? Maybe, but I am checking scoring guidelines as I'm going, and I see that they simplified, so might as well. Okay, part D. Part C had a lot to it, so let's see. Part D. The Maclaurin series for G, evaluated at 1, is a convergent alternating series with individual terms that decrease in absolute value to 0. That always means that you're allowed to use, excuse me, alternating series error or remainder. Show that your approximation in part C must differ from G of 1 by less than 1/5. So we did this in problem 3. Show that the actual G of 1 minus my approximation is a difference of less than 1/5. This is first neglected term. So we use the first two terms. The first neglected term was this one. So we should be able to show that 3 times 1 over 17 is less than 1/5. Well, how do we show that? How is 3/17? How do I prove that that's less than 1/5? I don't think you do have to prove it. I think you could just say 3/17 is less than 1/5. If you really wanted to prove, you could work on like a common denominator thing. What is 17 times 5? Let's see. 17 times 5 is 85. And you could say, hey, 15 over 85 is less than 17 over 85. So done, proven. When I check the scoring guidelines, it stops right here. Okay, that was a long problem. That's pretty complicated for this one. Lots of parts to part C. Part C, by the way, is 4 points. So you get points for writing the first two terms correctly of f prime of t squared, and you get another point for the remaining terms that you're supposed to write. And then you get another point for correctly writing the first two terms of g of x, and another point for the actual approximation. So 4 points in there.